All right, good morning, ladies and gentlemen. We're gonna go ahead and do some review today, review part 2. Okay, so a capacitor has two metal plates separated by some distance. We have a few capacitors up here. We've got this capacitor, we've got two plates separated by some distance, and then in this guy, we also have a capacitor separated by some distance.
Yeah.
Okay, I'm also gonna draw it on the board for us, because why not? Okay, so here's my capacitor.
You're looking at it from the end like that.
Okay, separated by some distance. If you move electrons from one plate to the other, you must do work. Okay, so if we move them from here to here, okay.
You had to do work
Right,
turning the crank on the Wimshurst machine.
So, oh yeah. So if you do, so I have to do, let's see if I can get to that actually. Nothing?
Nothing.
Here's this guy.
There it is.
Oh, that was so pathetic. Did you see that? It was like, okay.
Yeah, sorry.
Sorry, guys. What do we say? What can
You take an electron from the top. What does that do to the top plate if you take an electron away?
It becomes positive.
Yep.
And
And if
then
you put it on the bottom plate, what does that do to the bottom
It
plate?
becomes negative, right?
Because it's got one more electron and the top plate's missing one. And every one you take off the top and put on the bottom makes the top more positive, makes the bottom more negative. And in order to do that, you're taking electrons away from the positives. It doesn't want to do that, and you're putting them down where there's negatives. It doesn't want to do that. That's why it takes
Work.
work.
Okay, so if you move electrons from one plate to the other, you must do work. Now, I also want to talk about how that relates to this, right? So with our electron pump, we are moving electrons from one side of the plate to the other. And how am I doing work here?
Yep.
Okay, I'm doing work by cranking this crank. We're moving electrons from the one plate to the other plate, and we are doing work as we do it.
And what is the voltmeter telling us? Well, we'll get to that in a minute.
Okay, hang tight. Okay. Okay, and a uniform electric field appears between the charged plates. Okay, storing
Out of the positive into the negative. 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 Out of the positive into the negative.
Okay.
Please stop saying that, Mr. Black.
And what is being stored in there?
Electrical potential energy.
Okay.
And what does it mean if the field is uniform?
So it just means, uniform just means you're wearing the same thing, right?
Yeah,
Like
it's
when you
this.
go to
The field
prep
exerts
school.
the same force everywhere.
Yeah, exactly. Oh, that's great. It exerts the same force everywhere.
Yep.
And so I think we can answer this question now. What is being what is our voltmeter reading? It is reading. We're putting in work. We're moving electrons from one plate to the other. An electric field appears, and it is storing electrical potential energy. So this is reading what the electrical potential difference is between both the plates.
Per unit charge, as it turns out. We'll get to that in a minute.
Okay, so moving a charge in this field requires work. Okay, changing the potential energy of the charge.
And that's what you were just saying.
Yeah.
So let's. I think we need the little ball now.
Toss it in. Yeah. Okay. So if I toss this ball in here, what's gonna happen to it?
It's going to be repelled from the positive and attracted to the negative.
Okay. And if I want to move the charge up here, I have to.
You got to apply a force through a displacement. You have to do work.
Okay. So I've got it up here.
What happened to the work you did?
Well, it's stored as electrical potential energy,
That's
right?
right. Just
Okay.
like picking a bowling ball up off the floor and putting it on the table.
Mm-hmm.
And then if you let go, if the bowling ball comes off the table, it's going to be repelled from the positive and attracted to the negative.
Mm-hmm.
That electrical potential energy will do work, causing it to fall back to the other side.
Mm-hmm. All right. So that was moving a charge in the field requires work.
And we talked about this already.
Yeah.
This is review.
Okay, and here is our lovely equation. E for the electric field. Force, so the electric field is a ratio between the force and the test charge.
Yep.
Force is the same always, because no matter where I have it in here, if it's closer up here, we've got more repulsion, less attraction.
Yeah.
Up here, we've got more attraction, less repulsion, but it equals out.
It balances. You
It
get more
balances
one.
out.
It's like a teeter-totter.
Yeah. Okay. Teeter-totter is a good visual. You guys know what a teeter-totter is? Okay.
I don't know. They don't. Lawsuits have made them disappear from playgrounds.
Are you serious? Is
I
that
guess.
why?
I guess.
Okay, electric potential difference. Okay, so if we want to know what our electric potential difference is, our symbol for that is delta V. How do we get there? What is useful here? It's useful to know the work and the test charge, the ratio of those two together.
Yeah,
the
if
work
you've
divided
got
by
a
push
smaller
charge.
charge, it takes less work.
Yeah.
If you got a larger charge, it takes more work, and it's that ratio.
Yeah, and we know that work is force over displacement.
Yep.
Right? The force of the electric field that the charge experiences in the electric field, and the displacement, how far those plates are apart. And that's the same thing as saying our electrical potential energy right there.
And what the voltmeter is actually measuring is electrical potential difference. That's the work done divided by how much charge you're moving through the capacitor.
This is just like work changes energy. It's just electrical.
It's the
potential energy.
work energy theorem. Yes, ma'am.
It's all there. Okay. All right, and then last we have Ed. Okay.
Ed.
In a uniform electric field, the electrical potential difference is equal to the electric field times the displacement.
Yep.
Sweet. Okay. I think that's all we have. We are going to be taking the quiz.
Well, actually, we've got this worksheet, don't we?
No, that was for the caps. This one was after that. After the caps review, they just finished this one.
Okay.
Right. We don't have one after this one.
Okay.
So, all right.
My bad.